takes a second.
There we
Here
go.
we go.
All right. Welcome to CIJUG. Glad to have you all here. See some familiar faces and some new people. So good to see you. All right. Oops. And then I immediately mess up. All right.
No pressure.
Yep. So CIJUG stands for, or CIJUG, some people prefer that, Central Iowa Java Users Group. We're a volunteer-led user group for application devs in Central Iowa. Obviously, not just Central Iowa. Virtually has really expanded our horizon, so it's been kind of cool. Our purpose, learning, teaching, sharing, and networking with emphasis on Java, JVM ecosystem, but doesn't have to be. We do a lot of talks for non-Java related things. Jody's going to have one coming up. So if you're interested or know people that want to do a talk or are interested yourself or have any like topics you want to see covered, just feel free to reach out and on LinkedIn or Meetup, wherever, and we'd love to get in touch. Anyone's welcome, varying levels of experience and roles and interests. So yeah, glad to have everyone. All right. So we have monthly meetups, both virtual and in person. In person tends to be once a quarter. So primarily virtual to make it easier. Usually the third Thursday of every month, tends to be 5:30 to 7. There's a sessionized link there. We'll also throw that in the chat here if anyone wants to grab that. Bring a friend. Meetup's a good way to kind of keep in touch with our next ones, which is probably how you all found us. So next event will be May 8th, a little bit earlier than the Thursday. Let's see. So next one will be Jody. She's right there. Great talk. Highly recommend. We're gonna try a new thing with hybrid. So if you're in the Des Moines area, metro area, you can come in person, but also virtual. So we're gonna try that out and try and make it a good experience for everybody. Oops, wrong way. Couple just announcement things. No Fluff has a couple discount or a discount code for their CIS 2025. So if you are interested, grab that code. I'll give people a hot minute. Grab that. All right. Whoops. And then they're also giving out UberConf. These promo codes are really long. I didn't realize, but yeah. If you're interested in any of those, they always have great talks. The name fits. Like, there's no filler stuff. It's all really good content and straight to the point. So highly recommend take advantage of that if you're interested. And then make sure I am just clicking all the wrong things. Make sure you stick around till the end. We have a license for JetBrains to give out, and that includes any of these that you may be interested in. So one for, if you want PyCharm or you want PHP Storm, don't know who still uses that, but it's out there. IntelliJ Ultimate, so it's good for a year, I believe. So we'll do a wheel spin at the end, so make sure you stick around. And thank you for our sponsors, Source Allies, JetBrains, and NoFluff, just stuff. And then that's all I have, and I will introduce you to part 2 of Eric's talk on AI, and I'll kick it off to you.
All right, thanks. So now I'm going to do the same thing. I'm going to do the screen share and everything's going to go all over the place. So it's going to take me a second to move everything back to where I want it so I can actually see here. Yeah, it like moves. Why does it have to do that? All right, can you see the screen here?
Yep.
All right, I'm just moving y'all around on my screen. I've got like dual screens here. All right, so I'll just kind of chime in on that no fluff just stuff. In UberConf, I've been to UberConf not recently, but in years past, it is always awesome. And if you haven't been to Denver before, Denver is beautiful, especially in July. They do a lot of like hiking and stuff, and it's right on the mountain, right, like bordering the mountains. It's breathtaking, honestly. Just the scenery. So I would highly recommend it. It's always good content. So yeah, just to kind of put another plug for that. So part two. So I did this. What was it? January? Was I here? Was it January? February? Feels like it was like ages. Even Jody, like Dev Nexus, seems like it was like years ago. Even and we're only talking 6 weeks. So just a little bit about me, if you're not familiar with who I am. So I'm Eric Deandrea. I work for Red Hat. Currently, I'm a Java champion. Been doing software development for 26, 27 years or so. Been involved in open source for a really long time, currently and formerly. I do help run my local user group. So I'm in the Boston area. So I help organize groups just like this. We typically only do in person though. We've kind of taken a hard line where we don't do the virtual thing because we've had speakers even like fly in and then they're there and there's one person in the room and everybody else is virtual and it's just not a good experience. So, but in any event, I love to do the user group talks over the conference talks because I find that you can like get conversational and have a conversation with people. So at any point, if there's any questions, if you're not comfortable coming off mute and asking, put it in the chat. The folks here will watch the chat because it's like off somewhere and I'm not gonna be seeing it. So if there's a question in the chat, I just ask that like wait for me to stop talking and then ask it, but I'd rather address it like when I'm on the slide or when I'm in a particular piece of code to address whatever the questions are. So I don't bite, and especially from Boston, I'm not gonna bite you. So feel free to um, come off mute. So again, this is going to be a lot of information. You saw this slide. So it's the same deck that I used before, but we only got about halfway through it. And this space is moved so fast. There's probably like 30 more slides that I've added to it. So we may need a part three. We'll see what happens here. We'll try to get through as much as we can because, like I said, 2 weeks in this space is an absolute eternity. So what are we going to see? So these QR codes, the slide should be there. There's a workshop. All the code I'm going to show is still the same repository that I did last time. And I think last time we got through chat models. I think we got like to RAG, right? We're going to start talking about RAG. So at this point, you can probably see this list is probably longer than it used to be. There's a lot more stuff. For those who didn't see the beginning of the talk or have never seen LangChain4j before, I'm going to apologize. It just kind of is what it is. We're going to assume that because this is part two, I'm not going to spend the next hour and a half going through the basics again. But so at this point, we can kind of skip around. We don't necessarily have to go in that order. So, like, to me, it's all interesting. There's lots of interesting stuff here. I typically find like RAG is interesting. I think like guardrails is super interesting because it's how you protect against hallucination and you protect from bad things happening. So I definitely want to talk about that. Um, Function calling is interesting. So RAG, function calling, and guardrails, that's probably 45 minutes to an hour, just right there. So I mean, I can go in order. We can skip around. Whatever you feel is the best. What time do we need to stop? Yeah.
I believe we have till 7.
Till 7. All right. So till
Yeah.
8 my time. All right. So you just tell me, you just do this and say timeout. It's time to stop. And if we're not done, we can do a part 3. And I'm sure there'll be
Sounds
more
good.
stuff that at that point we might need a part 4. All right. All right. So hang on. Let me skip through here. RAG. Here we go. RAG. So kind of like I did the first time, I like to take a technology agnostic view of this because people hear RAG or retrieval augmented generation and they like to me it was totally confusing when I first started learning it. So like applying some terminology and some process and some nomenclature to things and then talking a little bit about the things that you need to think about when you're doing it regardless of the tech stack, and then as we go along we can say, oh yeah, this is what LangChain4j does for you or what Corpus does for you. So at the very basic, RAG or augmented generation is a process to enhance the knowledge of an LLM with stuff that it hasn't been trained on, right? And some examples of that might be like training is hard. Training takes a lot of time. Fine tuning is expensive and takes time. So data that's going to change frequently. Like I use like the insurance company example. If you work for an insurance company, your claims information, you're probably not going to fine tune your model on your claims information because that's going to change rapidly. You know, the claim as adjusters come and do things, that information is going to change. Your policy, like how your policies work and how your company operates and information about the organization, probably not so much, right? So fine tuning or baking that knowledge into the model is probably a better approach, but there's always kind of this fine line between what do you train it or do you use RAG? And RAG can be documents, it can be like web search, it's anything that has to do with as part of the retrieval process of interacting with the LLM, retrieving other information that you then send to the LLM to use as like additional context when it's doing whatever it is that it's doing. Right. And there's two real stages of this. And what I typically find, and I'm guilty of this as well, is when people do demos, they combine both stages in the same application, right? So it does some ingestion when the application starts up, and then they, use their chatbot example, they interact with the chatbot, and you can, it sees that it augments the data. But in like true production, these things are completely separate. Generally speaking, there's exceptions to everything, but generally speaking, the indexing, the ingestion part is probably something that happens either batch processing or you've got some event-driven architecture where data is being fed in. Maybe you're using change data capture or you're doing Kafka or messaging or, scraping transaction logs or some kind of event is triggering the change of a piece of data that is now you need to either ingest a change or ingest like new raw data. And whether that data is out on a file system somewhere in an S3 bucket or in a database or whatever. And then the retrieval part is what happens when you're actually talking to the LLM, right? And so I'm going to kind of work through these different stages separately. And I apologize for saying I'm just going to, my office, as soon as I shut my door, it gets really hot. Take my sweatshirt off here.
Eric, if you have a chance, could you throw the link to your slides in chat or we can wait till the end?
Yeah, I can do it at the end.
Okay, so
there'll be a QR code if we get to the last slide, but I can definitely put it in there. If you just go to speakerdeck.com/eDeandrea, it's there too. Excuse me. So the process of ingestion, you start by you need some document or some source of data, right? And in LangChain4j, there's like from the previous conversation, there's LangChain4j provides a bunch of building blocks for you to build whatever it is that you need to build on. And similar when we start talking about RAG, LangChain4j has different ways for loading documents or loading data, whether it's on the file system, whether it's on your class path, which file system and class path is what everybody uses in their demos because it's easy, but those are probably the least used in production, right? Getting stuff from a URL, you want to grab things from the URL or in an S3 bucket or in Azure Blob Storage or GitHub or wherever. There's a bunch of different loaders for finding the documents. Then LangChain4j has this abstraction just called a document, which so however you load it from, then you have to parse it. And this is kind of where it's part art and part science, because if you think about different data structures, and I like to use like a PDF of a book as an example. A PDF of a book has like a table of contents, and then it has chapters, and then the chapters have subsections, and then the subsections have paragraphs. And so things are kind of have like a hierarchical relationship. If you just go and parse the whole thing and throw it in there, it's going to be garbage. And so when you query it later on, if you're storing garbage, you're going to get garbage out. So this is kind of where like you have to know something about the data that you're processing. And you're probably, if you're getting data from multiple places or multiple pieces of data, so like a claims document versus a policy document versus information about the company, those data probably have different structures, and you should probably parse them differently rather than a catch-all. And so there, out of the box, there's text, there's a PDF one, POI. If you're not familiar with Apache POI is an open source project. It knows how to parse like Microsoft Office document types, so Excel, Word, Outlook, OneNote, all those things. And then Apache Tika is kind of like a catch-all. It can do kind of all of the above. something that we're working on now. So there was a project that's put out by IBM called Dockling. I don't know if you've heard of it, but it's essentially like a document parser. It's really has nothing to do. There's no tie to LangChain4j, but we had somebody from IBM present it to us, and we were like, oh, this is really powerful, like for being able to really fine grain control how you parse different documents. So we've started building that into LangChain4j now, a parser that uses Dockling for that. And it's just, if you go out to GitHub, I think it's GitHub/Dockling/Dockling. And it's an open source project that IBM started. And so once you have these documents and you've read them, then you've got to split them into chunks, right? Because just having a whole document doesn't really make sense. Generally, if you think about like on the retrieval side, you're going to ask questions. The user is going to ask a question and you want to find the data that's relevant, and you want to find it in a way where it's conceptually relevant. So I go back to my Apple example. Like if I'm writing a blog or I'm ingesting a blog about, in New England, they have apple picking season and different types of apples are ripe and ready for picking at different time frames. Some are in September, some are in October, some are August. But what that also kind of overlaps with when Apple Computer releases their new stuff, right, in October. So if I'm asking about like what apples should I go pick in October, I don't want to get stuff about the latest iPhone. Right. So parsing it and splitting it in a way. And then you have to think about, how do you want to split it? If the document is like a book, literally, do you split it by chapter? Do you split it by sentence? Do you split it by token? Because if you think about when we had that conversation last time about memory and token windows and whatnot, this is all extra data that if I ask it for my data, for the data from my data source first, and I get 3 results, if that's 3 paragraphs, that could be a crap load of tokens. And then if I'm starting my conversation with that, so it's like it's a balance between how much data is in a segment versus how much overlap do I want in a segment. Because generally when you split this, you want to overlap your segments a little bit too. So if you just pick, like, for an example, a sentence as a segment, you probably want a couple of words of each, the previous and the next sentence, to overlap. So that way, when you're querying on the query side or the retrieval side, you might get both sentences as results. And then you can just decide like which one is more relevant and decide whether you want to keep it or throw it. Right. So like I said, it's kind of part art and part science. And this is really the hard part. Like the writing the code to actually do this is easy. Thinking about how you want to do it is the hard part, in my opinion. I saw there's a question. What do I think of a parser that goes and parses using images of every page to markdown, similar to the agent you showed just? Yeah, I mean, that might not be RAG, or you could use it in RAG. Like there's plenty of examples of reading images and spitting it out. And actually that's what Dockling does. So you could hand Dockling a document of images and it can spit out JSON or Markdown or text or whatever. So our goal with that is to adapt it to this document abstraction that LangChain4j has. So it can take all these things and bring it to that. But
there's nothing out of the box.
What was that?
Sorry, but there's nothing out of the box. Basically, what I ran into, like all the parsers in LangChain were kind of allowed me to do text, but
Yeah.
the text uses loses all the all the table stuff is
Yeah.
garbled. All
Yeah.
the images, if anything important is an image. But if you go to ChatGPT or Claude and go and like do a screenshot and say, "Hey, give me Markdown of this," it does
Yeah.
a pretty awesome job.
Yes, it does.
It's like I wonder if anybody like cared enough to do this thing, or
That's what Dockling does, and that's why we found
Dockling.
Dockling very interesting.
Okay.
Like because they
Okay.
showed some examples, they took a PDF that had charts and graphs and
Yeah.
whatnot, and it actually generated it, and it did a really nice job in Markdown. So as soon as we saw that, we're like, okay, I know what we're going to do with that.
Thank you. Thank you.
So that's we're working on that now. So yeah, so there's, again, in LangChain4j, there's lots of different built-in things for splitting documents. And again, we're, kind of like Lada mentioned, mostly focused around text at this point. So whether you want to split it by paragraph, line, sentence, word, character, regular expression, or there's the one that everybody uses in their demos is the catch-all one, just called, you basically say, I want to do it recursive. I want each segment to be 1,000 tokens and I want 50 token overlap. And it'll kind of go, okay, let me do it by paragraph. If that's still too big, it'll do it by line. If that's still too big, it'll do it by sentence. If that's still too big, it'll do it by word. So it kind of applies these in a recursive pattern. It's a good catch-all for getting started. And for simple things, it probably works well, but for more complicated things, it's probably not the best way to go. And then once you have that, now you've got this document parsed and split into different segments. Now you've got to compute embedding, and what an embedding it. And I don't know exactly like the mathematical concept behind this, but it's essentially taking this text and computing it into a mathematical graph of data, and that's how it understands context, right? When you do, if you've ever done anything with graph databases or whatnot, it's like finding point, basically plotting all these things on a graph and finding out which ones are near and which ones are far. So that way, when you're searching it, if I find one hit, you're finding the ones that are closest to it. And that's how it kind of gets around Apple Computer versus Apple, the apple that you eat. Because when you send this data to or when you query it on the query side, you're going to be querying it as vector stores and as a vector embedding. But what you need to send to the LLM is the text, right? So you don't want to just store the embedding. You want to compute the embedding, but you also want to store the text with it because you don't want to have to go backwards each time you're doing a search. So there's plenty of embedding models that are out there. There's some in-process ones. Amazon has one. All the major cloud providers have them. Hugging Face has them. There's plenty of these embedding models. And what you see too, like if you were to ask ChatGPT, hey, compute an embedding for this, it'll do it. And you'll do it right in the chat interface because ChatGPT and Claude and whatnot are multimodal. So they give you one interface, but it's actually different models behind the scenes so when you ask Claude to generate an image versus summarize something versus do an embedding, you're making the same API call, but they're using different models behind the scenes based on what you're asking. And they've built that infrastructure. So, but when you're doing it as part of an application, you've got your chat model, you have to have an embedding model. If you want to do images, you have to have a model that supports that. Some only do text to image, some only do image to text, some will do both. So it depends on what you're trying to do. And then once you have the embedding, you want to store it somewhere. So this is kind of like you've got this process, which is keeping track of data and keeping data up to date and ingesting it, kind of like if you think about ETL. I kind of call this like ETL on steroids. If you're doing ETL, at some way, shape, or form, it ends up in a database that your application talks to. And that's kind of the same thing here. It ends up in a vector store, and the vector store is storing the numerical data, but it's also storing you can store metadata with it as well. So you always want to store the text that generated it. But if the data, maybe you're ingesting different data that's user specific, you can tag the data that it came like with key value pairs, just like kind of like headers, like you would with labels or headers, like you would with anything else. And that becomes important on the retrieval side because then you can filter data on the retrieval side based on whatever you store as metadata as well. So yeah, is that everybody's head spinning now? So like I said, the code is the easy part. So like doing the ingestion is actually really easy. Once you have your embedding store set up and configured in your embedding model, you can do like transformation. So this is like for each document where you can put metadata in, maybe it belongs to some user ID, or maybe you can store like where the data came from, like the source of record of the data. So that way, when if somebody asks for, give me your sources, you have the sources of where the data came from as part of the metadata. In this case, it's splitting it by 1,000 tokens with a 200 token overlap. Then you can transform it. So in this case is like, where did it come from? And if it came from a file, the file name of, LangChain4j as part of the document object will give you the source, like the URL or file reference to where the document came from. And so you can add that. And then like the last line, the ingest is the easy part, right? You just set up a loader, set up a splitter, set up an ingest, and you just call ingest, and that does all the magic. When ingest is done, the data will be split, it'll be parsed, and it'll be in your embedding store, and it's there. All right.
Looks like Ovi, maybe you have a question?
Yeah, go ahead, Ovi.
Yeah. Hey, Eric. So quick question, right? So there are embedding models to create the embedding out of the content, and we store it in a vector database, right? So when someone querying, right, what we have to do, right? We have to use the same
I'm gonna get to
embedding
that.
model
I'm gonna get to the query part in a
Oh,
second.
okay. Sorry. Yeah.
Yep. So this is the ingestion phase. So this, like what I
Okay.
typically see that like organizations that can kind of do it on demand. I don't know if you've ever, I had one organization I was working with where if you're not familiar with what change data capture is, so they use a technology called Debezium. So they have like a big Postgres database, and as transactions happen and as data changes, with change data capture, it reads the transaction log of the database and it transforms those transactions into events that go out to Kafka. And then there's a Kafka connector, or they have an application which is a listener on a Kafka topic. And so as data gets put there, it reads it and it goes through the ingestion process and it puts it into the vector store. So it's not like a big batch, it's happening more in real time. But there are times I've seen it run in batch like once a day, maybe it doesn't change that frequently. You just want to do a weekly update or that kind of stuff. So it all depends. I see someone's got their hand up.
Yeah. So just a quick question. So the tokens, the number of tokens that we use, does it have any bearing on how the embedding would finally work? In a way, like, will the inherent meaning be lost when we do the search? When the context is getting generated based on the search?
Potentially. So if like in this case, if you're saying 1,000 tokens, whatever that is, if it's a paragraph, it could just stop in the middle of a sentence and then create a new segment from that. I mean, it very well could. It could also, like if your token size is too much, when you search, you could have irrelevant stuff like as part of the segment. So like this is where it's like more art than science here, and it's kind of depends on, you probably don't want to use the same strategy for each type of document or for each different classification. Maybe you've got a bunch of documents. It's kind of like strangling a monolith or doing modernization. You bucket your applications based on characteristics. You're probably going to do that with your data. You're going to put them in buckets based on the structure and maybe apply a similar pattern to each kind of bucket of document, and then you change the way you do it. So there's a lot of experimentation like with this to figure out what the right approach is, and there's no like somebody can't come in and say you're doing it wrong. Like it really, there's so much variation here. It's
Got it. So it's case by case basis, and then
Yeah.
like, again, it depends on the type of the document that
Mhm.
that we are actually using.
Yeah, so like back to Lada's example of like a table or a graph or something. If there's a table or a graph in your document, you might just want that table with its caption as one segment, but the paragraphs around it as another segment, but with some overlap. So it really, really depends. And LangChain4j is going to give you like the building blocks, and it's enough to get started and to do some demos. But if you really want to get serious with this, you're going to have to do some customization. And this is where you kind of have to know about the data that you're ingesting.
Got you. Yeah. Thank you.
Yep. Yeah. So now let's look at the other side. So this, on the retrieval side, it assumes kind of like an ETL job with relational databases, that you're just starting up your application and there's a database there that you're just hooking up to, right? How the data got there is like magic. You don't really think about it too much, but, except when your application blows up, because it's always a data issue, right? So the first part of this, the user. So I'll just use the chatbot example just because it's easy to grok conceptually. So the user in the chatbot, say I have a chatbot for American Airlines, and some user logs in and wants to change their flight, right? And they're using the chatbot to change their flight. So the first thing if they ask a question and say American Airlines has like all of their cancellation policies, as rather than fine tuning their models, they've decided to do RAG. And so they've got all their cancellation policies in a vector database. So the first thing it's going to do when they start asking the question is it's going to first compute the embedding for the question, right? So you need the embedding model as part of this step. So if you're calling ChatGPT, that's money out and money back, right? Because there's token windows going back and forth. Then you're going to get back the embedding for that. And then you're going to query your vector store with that embedding, and you're going to get n number of results, however you decide, right? You don't just want one, you don't want 100, because that's all data that you're going to have to send to the LLM. You want, I don't know, 3, 5, 10, and you probably want to aggregate them based on what the similarity is. So a lot of people use like cosine similarity. You define some threshold that, the results should be, less than 10 that meet my criteria by 70%. I'm picking a random number here. And so you get those results back, and you probably want to rank them and order them by most important to least important. Right. And then you stuff it. So that's kind of one prompt technique is you take what the user did. You've got your system message, you've got the user message, and then you're going to append to the user message. You can say, hey, and by the way, use this data in your response. You're going to take all the data you got from the vector store and you're just going to stuff it in there, and then you're going to send it. Right. And the LLM is going to churn on it. So you've basically fed the LLM data that it didn't know about before that it can use as part of its thinking process to return. Right. And so it's the code again is pretty easy. So there's two parts to this in LangChain4j. There's the retrieval augmenter, which is how to fetch the data. So this is where you can say, how many results you want, what the scoring is. If the data of if I'm a user and then there's data in the vector store that's specific to a user, you probably only want to query against data that's specific to that user. So this is where you can start to do some filtering before it returns results. And then you just, you ship it back. Right. So that's the easy case. The more advanced case, and this is where like agentic AI starts to get involved a little here. And there's when I start to talk about tools, we'll talk about because you can kind of see where RAG might fit in with a tool invocation too, like where you give the LLM a function call to your database. And so now that's not RAG, that's function calling. But in the RAG use case, you can have maybe you've got multiple content sources, or you want to combine a web search as a part of the RAG process. You want to scrape maybe your Confluence site. You've got an internal Confluence site, a subdomain of your Confluence site, and as well as looking at documents that you've put in your vector store. And then each source gives you back results. And then you want to overall aggregate them together and just pick the top 10 and send it. So this can get like far more complicated, but the code is still pretty easy. So in this case, like I'm using a Google search as well as an embedding store retriever. The Google search and the web search retrievers are already all built into LangChain4j. So if you want to do Google search or web search, or there's a good search engine called Tavily that's out there. It's not free to pay for it, but it's really geared towards organizing and structuring and querying data for LLMs. And then the difference here is the query router, and there's different types of query routers. And I'm going to show some code in a second, but there's a question. Do you have a way to deal with duplicate information in the vector database? Say someone parses the same doc several times. So if you search it, it shows identical 3 entries. So if it truly is identical, you could filter that out and make like a select distinct, like if you were to think about it in relational terms. But if it varies just a little bit, you could do things like after you order it, if they have the same score, then you could do like a similarity comparison between just the two of them. And if they're like 99.7% comparable, then you throw one out. I mean, there's lots of ways around that. The vector stores themselves, I don't know them well enough to know if they would do that for you. I don't know, but those are some things that come off the top of my head. But you're right. If someone stores it, this is kind of goes back to garbage in, garbage out. If you put garbage in, you're going to get garbage out, and it's going to affect the performance of the retrieval part. Does that make sense?
Thank you. Yeah, thank you.
All right. So I'm going to go to some code here. Just to show a couple different examples here. So this application, if I go say CD4, I run this application in my dev mode. So this uses Postgres and uses PG vector, and I'll go through the code in a second. I'm just going to show the application here. All right, app is up. Of course, the window opens on a different screen here. Hang on. So I built a little application called the Quarkus Help. And so I've got some documents that again, every demo does, when it starts up, because I haven't separated the ingestion from the retrieval like everybody else. So I have just in source main resources, I took the contributing guide from GitHub. And of course, that opened on another screen as well. Hang on. I took the contributing guide, which is a markdown, and I converted it to PDF and I stored that. So it's just the contributing guide, right? From GitHub. So I've got that, but I've also got, if I kind of show the code here, source main Java, rag retriever. So the ingester is pretty easy. The ingester it starts by cleaning out the database, at startup, wiping everything out and basically redoing it. So I'm using OpenAI to do that, and I'm just 500 tokens, and then it's splitting and ingesting it, and it's just loading the documents from the file system. And then the retriever here is looking in the embedding store. It's building a web search, but my configuration for the web search, if I go to my properties file, is where is it here? GPT Tavily. Yeah, so I'm using Tavily, and I'm giving it just the Quarkus.io domain. So it's going to do a live web search of just the Quarkus.io domain as part of the RAG. And in the default query router that I've done here, like I've got a couple examples here. The default one basically just sends it to all of them and then gets all the results back, right? And it can do it sequentially, you can do it in parallel, it kind of, however you want to do it. So I can come here and say, give me my little chat bot. Hi, I'm Quarkus Help. My chat interface, if I show you if you remember our the way our agents work, and it uses a WebSocket. So your Quarky, a friendly question and answer agent, knows everything about Quarkus. If the question's unrelated, just politely reply that they should use Google instead. So like if I tried to say, can you rebook my flight? Can you rebook my flight? Sorry, I can't assist you with rebooking your flight. Contact customer service, right? Because it doesn't know how to do that. But what it actually did, if you look at the logs here, all right, so here's some logs. So the first thing it did is it went out to Tavily and issued the query to Tavily. So this is where like just sending it to everything probably isn't the best idea. You probably want to have some smarts in front of it to detect this case before, like, because I just wasted a call to Tavily and the user had to wait for it. I paid for it and I probably shouldn't have, right? And then the response from Tavily came back with whatever it came back with, and then it took that response from Tavily and it stuffed it into the prompt, and then for the LLM just to read the system message and say, I can't do that, right? I don't care what Tavily told you. You told me I don't know how to do that because it's not relevant, right? So now if I say, what do you want to know about Quarkus? Somebody speak up.
How
What is
do I
it?
install it?
How do I install Quarkus?
Yeah.
Yeah, so now it's probably getting this from the website, I would think. Yeah, see, it's even giving references and markdown references to things and where it's coming from.
Nice.
So like and then if I say, how do I contribute? It probably didn't get anything from the contribution guide. How do I contribute? Yeah, now it's going through, how do I contribute? And if you look at what it's actually doing here, so let me get back to the end here. So it's doing streaming. So this multi-return type is an asynchronous return type. So you notice the responses are coming back in chunks. So it's streaming token by token, and it's pure streaming. So it's got like back pressure and all that good stuff. If I change this just to string, it would be fire the request, wait for the whole response, and then send it in one shot. So you would see my question, then it would be wait, and then boom, here's the answer, rather than seeing it kind of a word at a time come in. So let's see here. So it did, let me find the log here. Yeah, so here we went to Tavily. The query was install, which is, you notice it's a little different. I didn't say install Quarkus instructions. It said, how do you install Quarkus? So it kind of retooled the question a little bit, and then it came back with an answer. And it can even, Tivali can even suggest potential follow-up questions that you might propose to the user. And so it has all these references and the URLs of where they came from. So Tivali will give you all the references to all the things that it finds. And then you can even see, I'm not logging the interactions with the embedding store, but it calls to the embedding store and it stuffs that in here as well. So if you look at the user prompt, it's actually quite big because it's stuffed all that extra information into the prompt. All right, so that's that. But then I could, if I wanted to change something, so instead of using like the default router, right, I could use this router instead. And oops, finish uncommenting. So this router, I can actually use the same LLM or another LLM to decide what to do. So I can give it a reference and kind of name, like I've got a way to look at local documents. I've got a search of Quarkus.io. I can send a query to another LLM and say, hey, this is what the user asked. These are the kind of data sources that I have. What do you think is the most appropriate, or should I do both? And it will tell you what to do. And then based on that, it'll kind of decide on its own which one to call and when. And if it fails for whatever reason, I give it a fallback strategy. I can say, if for whatever reason it dies or it times out or whatever, then just go to all of them. My result might not be as good, but better to have bad results than no results or blue screen of death. And then when you get the data back, if you go into multiple places, right now I'm not aggregating. I'm just basically taking them in the order that they came back. I could do, so there's like this re-ranking. So I could apply a re-ranking aggregator, which is provided out of the box by LangChain4j, to say, okay, now I have another model which knows how to score things and compare them against each other and rank them. So now I want to send the query and I want a minimum score of 60% match. And so now re-rank them in the order. So when I send them to the LLM, they're in the right order, and I've dropped any that don't meet a particular criteria. Or you can build your own. Like you can go completely haywild and build your own. So I didn't actually build this. I got this from somebody else. I don't actually know exactly what it does, but she gave me an example of something complicated. And I don't know exactly what it does. But at the end of the day, it's just an interface that you can implement and do whatever you want with. Right, if you want to build your own. Right. So that's kind of the advanced RAG, and I just kind of showed you the code. Yeah, there's lots of stuff that's going on. But it's pretty easy. So LangChain4j has this thing called Easy RAG, and Quarkus extends it a little bit too. So if you just want to get off the ground running and you don't really want to give a crap about doing this, you just want to play with stuff and maybe you want to play with your ingestion strategy, you can use this Easy RAG dependency, and it just kind of sets everything up for you, which is kind of what I've done. And unless you override it, it'll just give you a default ingester, a default aggregator, a default this, and a default that. Then in Quarkus, if I just start providing beans of, like, I'm producing a bean of type retrieval augmenter, Quarkus will say, oh, you gave me one of these things. I'm not going to use my default one. Let me use the one that you provided for me instead. So it's a way that I can override that. And same with like the way it does ingestion. If I just provide a bean of that type myself, it'll just use it. Do I have a way to oh, I already answered that question, the duplicate data quit, didn't I? Okay. All right. So we all good here? Everybody get it? Everybody good with RAG? You're now all experts on RAG, and you could go implement RAG and talk about RAG and what RAG is. All right, so now let's move on to function calling. So whether you call it function calling, tools, agents, agentic is the new hot buzzword, and we'll talk about MCP and agentic in a little bit. But essentially, agents or tools or function calls is a way, like kind of like RAG, you're extending the model with additional knowledge. Agents and tools are a way to extend the model with additional capabilities, right? So when I first saw this, I was kind of like if anybody's ever done like JavaScript programming and you always say, do not ever eval, like don't ever just take blind a string that could be JavaScript and eval it, right? Because that could be a security hole. That's essentially exactly what we're doing here, is you're basically taking a block of code, you're giving it a name, and you're handing it to the LLM and say, hey, I have some stuff that you can do and you can call. And you're just blindly letting the LLM call it for you. Right. So that's like the conceptual. So, think of all the things that could possibly go wrong there. I'll let you just stew on that for a second. So you're building these capabilities or code or functions or modules or whatever you want to call them. You're extending it with natural language descriptions, both the function itself and the parameters of the thing. And then when you send the request to the model, as part of you send the system message, user message, there's also a section in the body, and it's different for every provider. So how it looks for OpenAI is different than how it looks for Anthropic, is different than how it looks for like OWAMA or whatever, but it's all the same information. So essentially there's a block in the body that describes the tools that are available to the model. And then the model, as the response, instead of having like the assistant response, could have a tool request response. And it'll provide the name of the tool and it'll provide the arguments for that tool. Now, models hallucinate, right? We've all seen that before. So this is a point in your application where things could just go horribly wrong. Like it could say, oh, call this function, which you didn't tell it that it had. Or it could get the arguments wrong. I mean, it tries to infer the types and in the right order, but it could just get the arguments wrong. So that would obviously blow up. If it tells you to call a method which doesn't exist, you can't bind to, then bad things are going to happen. So yeah, so all kinds of bad things can go wrong here. But doing it is easy. Like again, to do it, like actually doing it is the easy part. So with LangChain4j, when you're building, if you're using the high level abstraction, which is really the only way to do it. So when I did the part one, or for anybody who was with me in San Francisco yesterday, when I talked about you've got kind of the declarative and the programmatic approach, the tool stuff is now something we're starting to be kind of a higher level abstraction, and only applies to the declarative approach. So you can, in LangChain4j, you just have, when you build your service, you give it the model, your memory, and there's also a tools, and you just give it instances of classes. You can give it more than one. You just give it instances of classes, and those classes have methods with tool annotations. And the tool annotation is something that describes what the thing does. You probably, like string S and int X are probably not very good, because the model is not going to know what S actually means. So you probably want your parameter arguments to be descriptive. There are other annotations you can put on. I think it's like at description is what it's called, where you can describe in natural language what the parameter is and what it does. So you can be more descriptive. Like the more descriptive you are here, the better, and the better chance you have of the model doing the right thing when it calls back. Generally, I find the ones that you pay for, like ChatGPT and Claude and whatnot, are very good. Though anything that can run in your machine is typically very bad. And try to call your tool when you don't want it to, and it'll call your tool when you don't want it to, right? And it'll give wrong arguments all the time, and bad things happen. So that's kind of like anything that you can run on your machine is not good for production testing, because it's just not, it's not a good thing. So with Quarkus, again, you have this interface that you build. You put this register AI service annotation, and then you can either register, because you can have multiple interactions with that model. So you can define multiple methods, which could be like multiple, like you asking different types of questions to the model. So you can apply tools to just like one particular interaction, or you can provide it at the class level for all of the interactions of that class. And so in Quarkus, you just tell it the name of the class. You don't give it the instance. And then you have to provide a bean of that type. And then it's the same, like that at tool annotation is the same one. It's not, Quarkus doesn't have its own annotation. It's the same annotation, but the toolbox annotation is the same annotation. Eventually, this annotation model is going to move up to LangChain4j as well. But right now, like this way you do it with annotations, like the toolbox and whatnot, is specific to Quarkus. And so what's kind of interesting, if you like this is a simple thing from Quarkus. So if you're familiar with like the repository pattern, if you've done like Spring Data JPA as an example, Quarkus has something called Panache, which is essentially the same thing. So you have this like Panache repository, it gives you all of your CRUD methods. Well, maybe you've got some business methods like cancel a booking or find bookings for a customer that are part of your repository that you've already written. You can expose those now as tools because this repository is already a bean. You can now expose like it's a transactional thing. Now, I'd say be very careful, like differentiating between read-only operations and write operations, because again, think of what could possibly go wrong if the model calls something with the wrong arguments and it's not idempotent or it mutates data, so it's something you kind of have to think about. You can also do so in Quarkus if you want to build like a REST client to some other API, for example. In this case, it's like the weather. There's a publicly available weather forecast service that's out there. You can ask, it's called Open Meteo or Open Meteo. You can define like this interface that represents the REST call using the Jakarta RS and the REST client. And now you can expose this operation just as a tool, right? You can even give access to other LLMs as tools, right? So this is where you start to get into like they start talking about agents, LLMs that can call other LLMs. You can define, like in this case, I might have an operation that looks like this. I have an agent that maybe it's a weather forecasting agent. So the weather forecast service only takes latitude and longitude. So, but the user's asking, what's the weather in Des Moines? Right. So there's another service out there that can understand, and it's another model that you can take the sentence Des Moines and figure out or what state it's in. And then there's another service that's out there that can geocode that and return latitude and longitudes. And now you've got this agent, which is AI based, which has access to all these different tools. The tools on their own don't know about the other tools, but the top level agent has access to these tools, and it doesn't necessarily know that one of the tools is actually another LLM, right? So you can start to build these. This is kind of where the word agentic comes from, is being able to, the LLM is in control of this, where traditionally, when I talked last time about, you can have an AI replicate or pretend to be a human or replicate or pretend to be software. This is software, right? You would generally write this workflow either in Java code or using like Drools or a workflow agent or something. You can now let the agent or the AI do this. And again, what could possibly go wrong here, right? Which is why I have a section at the end of this that talks about, okay, how do you control this and how do you test all this, right? Because you're getting in, like everything here is now non-deterministic, right? So like to build this thing right here, like these like 10 lines of code is really all you need. So building it is extremely easy. So you've got like an AI service that's your forecast agent, has access to these other tools, and the extractor agent is another AI service which knows how to go and get and answer questions. It knows how to extract the city from a question. And then you have a RESTful client, which isn't an AI service, that knows how to go and get the forecast given a latitude and longitude. And it's the top level agent that's doing all the coordination and figuring out what needs to happen and in which order. And you need to be able to trace that, right? So when things go wrong, not if things go wrong, when things go wrong, you need observability. So you need distributed tracing. You need to be able to go back to your logs and aggregate all your logs together. So all these operational concerns, what happens when bad things happen, what happens if something times out, what happens if a service is down, like all these operational concerns that aren't part of your functional requirements, you still have to worry about as part of this, right? But you don't have control over it because the AI is orchestrating everything for you, right? I touched on web search. Like web search is part of the RAG process. You can also use web search as a tool. So you can give the LLM access to do web searches as part of its response, and it's not part of the RAG process. So the same web search, there's a tool in LangChain4j called web search tool, which essentially wraps, there's like an under layer and then the RAG version of it, and then the tool version of it kind of extend, but it's the same Google search and Tavily that's under the covers. And so you can expose that the search as a tool to your LLM, and you don't have to write the web search. Like it's just there as part of LangChain4j. You can use Tavily, you can use Google, you can use, whatever it is that you want to use. So yeah, so risks, bad things can happen. Prompt injection, like this is like if someone can understand like the way your thing is structured, they might be able to engineer a prompt that gets it to do bad things, right? Just like if an attacker understands like, oh, you're using struts version 1 and I know it has this exploit, I know how to exploit it. If they can figure out how to structure their prompts to do bad things, then bad things are going to happen. So auditing, like I think I talked about auditing last time, like being able to audit when responses and when requests come and go, and being able to have an audit trail of what happens is super important. Drawing a line between what operations are read only and what operations you want to give write access to, and then having controls and security and role-based access controls around who can do writes, and it opens up all that whole conversation again. All right, so that's tools and kind of the beginnings of agentic, because you can use tools when you start getting into agentic architecture. I didn't talk about like model context protocol. I have a whole section to talk about MCP and model context and whatnot. That's just like you can do agentic without doing MCP. And I'll talk about what kind of what the difference is when I talk about MCP, but you can do it's essentially giving agents control to make decisions and control of your workflow. Yes. Is it Sumit or Summit? Sorry.
Yeah, hey Eric. So if you could go to the two slides back. Yeah, one more actually. Okay, I think I'm talking about the agentic model that we had. Yeah.
This one?
One more. Sorry. One more. Yeah. So here. Like you said, so it's all AI orchestrated.
Mhm.
So let's say in a normal coding style, what we would do is we know that the user asked for, let's say, for a city location, for a city, what is the weather? So the agent using the LLM, we are able to find out the city, and after that, can it be, instead of letting the AI determine what's the next path forward, could it be um, kind of direct, or in a way hard coded, or maybe a static calls to these different tools, instead of AI being the orchestrator, wherein we know that it's a probability
Mhm.
whether it's
Yeah,
going.
you absolutely could. So in that case, like here where you've got the forecast agent, which is kind of this top level thing is the agent. I don't know if you can see my mouse, but the top level thing, you could code this yourself, and your business logic could have access to all these other things, and you could define, and that's traditionally in software engineering how we would do it, right?
Yeah,
You would
correct. Yeah,
define
that's
like a
right.
business tier, and it would have the workflow that was completely deterministic. But
Correct.
now the cool kids don't want to do that anymore, right? I haven't quite jumped on the bandwagon yet, so I still don't know if this is a good thing or a bad thing, and it kind of scares me a little bit. But this is like where industry is going and what people are doing.
Correct. Yeah. If everything is non-deterministic, we don't know what can go wrong, right? So we would
Yep.
definitely want to have less of non-deterministic workflows. All right. Yeah. Yeah.
So absolutely, this is what you would generally write. This would be your business logic, right? And now we're farming out our business logic and just letting something else do it because in my opinion, we're lazy. But all right, so guardrails. Guardrails are a way for protecting when bad things happen, because I'm sure you've all heard of some of these examples. If you haven't, anybody not hear about the guy who convinced the Chevy chatbot in Michigan to sell him a Tahoe for $1? There was that one. There was Air Canada chatbot. Like the guy canceled a flight because the chatbot told him about the cancellation policy, which apparently was wrong, and then they wouldn't give him the refund, and he took it to court. And Air Canada tried to. Their claim was, well, it was the software. It wasn't a person that told them. They were like, well, tough luck. If it's representing you on your website, then whatever it says, you're liable for. Microsoft, Blender, this other one, this little chatbot on the bottom right corner here. This wasn't actually a production thing, but it was somebody, so if you know Stefan Jansen and Mario Fusco, they were doing a talk at, I forget which conference, but they were doing a talk at a conference and they were basically showing how to hack things. And so this is like how they got around the chatbots programming to get it to do something. They basically got it to give a 5-year-old like $1,000 back by telling it, oh no, we're just role playing. We're just going to role play. I know what you say, but let's just role play. And because they knew it had access to these tools, they knew how to engineer the prompts to get it to do something that it shouldn't have done. Right. So these are all the bad things, and you don't want you don't want your company on this board here of, yelling at somebody or calling Mark Zuckerberg bad, a 4-letter word. Whether he deserves it or not is a different question, but you don't do it publicly. So for now, guardrails, everything I'm going to talk about now is only in Quarkus. That being said, I've already implemented it in LangChain4j. The PR just has not been merged yet. And the reason is they're trying to get a 1.0 release out the door, I think like the first week of May. And so they're doing a ton of like API cleanup and breaking API changes, and they just didn't want to, this came in too late. I've been working on it for about a month. So it probably won't make 1.0, but it'll be merged shortly thereafter. Because it's one of those things like the process we take, because I work in all three. I work in LangChain4j, Quarkus, LangChain4j, and Quarkus. We generally build these kinds of things in Quarkus first, and because we can ship it really fast and get feedback, and then we'll rework it a little bit. And then for something like this, where it probably makes sense, it really belongs up so that everybody out, not just Quarkus, gets it. But the behavior is a little bit different as well, because the way Quarkus does things different. So it had to be generic enough, like, class load, thinking about how class loading and stuff works. But in any event, it'll look almost exactly the same in LangChain4j. The annotations will look exactly, everything I'm going to show you, it'll look exactly the same, but it's coming. So the purpose of these is to do validation of both input and output of the data that goes to the LLM. We're also going to extend this to tools. It hasn't been extended to tools yet. So before you invoke a tool, being able to validate the input and the output of the tool call as well. We just haven't gotten there. And you can chain them together, and they run sequentially, both on the input and the output. And you can decide how you want to handle failure, whether if you've got like 5 of them and you want to stop at the first one, you can stop at the first one, or you can process all the way through and, kind of get like a correlation of all the problems to send back to fix. So when we talk about an input guardrail, either passes or fails, right? So it's pretty easy. Either you have something that maybe can detect prompt injection, or has to meet certain requirements. And so if the guardrail passes, it's great. If it doesn't pass, the LLM never gets invoked, and it throws an error or an exception that your application has to handle. And that's part of your error handling strategy, right? Your fault tolerance is an input guardrail exception. And that's how you would handle that. An output guardrail, though, has a bunch of different outcomes. So there's success, and if you've got a chain of them, everything was good, and you move on to the next one. You can fail fast, like just stop now, don't process anymore, and let the caller handle it. You can do a retry, right? Because we all know these things. If you ask it the same question twice, you get 2 different answers, right? Which is kind of bizarre, because like when your GitHub action fails, you run it again in hopes that it's going to pass, but it's deterministic, right? But in this case, it's non-deterministic. So you might just resend the same chat history and do it again and see what happens. Or you can issue a reprompt. So in the example I like here is you ask it to return JSON, and it returns something that isn't JSON, or is JSON and doesn't match the object that you're expecting. At that point in the guardrail, you know what you're expecting, you know what the failure is. So you can send that same user message back, but add additional things to it to say to the LM, like, hey, I really expected you to answer only in JSON and in this format. Please do that. And it'll send that back to the LLM, and hopefully the LLM will do it again. And you can have like retries on these guardrails. They can try it 3 times and fail. If you have a chain of them, like 4, say the 4th one fail, the first 3 pass, the 4th one does a reprompt or a retry, and the LLM responds. Now it's got to go back to the beginning of the chain and re-execute, because if the LLM responds to a reprompt, the new result could violate some of the previous guardrails that you already executed. So you've got to kind of rerun, and LangChain4j takes care of all of this stuff for you, right? So in input, so this is specific to Quarkus. When it hits LangChain4j, it'll look exactly like this, except it won't be a CDI bean, right? You just create classes, but the annotations and everything else I'm showing here will look exactly the same. So for an input guardrail, the simple cases, you get access to the user message, and you can do, like in this case, it's checking that it's all uppercase. If it's all uppercase, it successes. If it's not, it fails. And if it fails, it throws an input guardrail exception that your code has to handle, and then you can read the failure message or tell the user and do something else, whatever you want to do, right? An output guardrail looks similar. You get this object, and the object name is different in LangChain4j because we cleaned it up a little bit and did some naming changes, but it's essentially the same object that's got a bunch of stuff on it. It has the response, it has the access. Like if the prompt was templated and had parameters, it has the values of all the parameters. If someone's got their hand up, go ahead.
Yeah, there's just a few questions in the chat. Figured
All right,
I'd.
let me get
go
to them
ahead.
after I talk to the slide, and then I'll.
Okay, sweet.
So in this case, it's looking at the response that comes back, and it's again checking if it's all uppercase. If it's all uppercase, it returns success. If it doesn't, it says, the output must be all uppercase. Please provide the output in uppercase. So the same request will go back to the LLM, but that additional message will get added to the LLM to try to steer it to do something a little bit different. And it can retry. By default, I think it retries 3 times. Like the same guardrail will retry the same logic 3 times before it'll finally give up, or it's configurable. You can configure how you want it to work. And then you register it just kind of like you put the guardrails on here. You can apply them at the class level. You can apply them at the method level. The method level always takes precedence, just like, everything else in Java. And they can have multiple values. So what we typically say is, the guardrails are supposed to be the exceptional case, right? They're supposed to catch exceptions. So the one that's going to catch the most exceptions the fastest should be the first one, right? Because they get executed sequentially. So if a guardrail has like a monetary value, if it like for prompt detection, you might call another LLM. You probably want to do that last because that involves money, or it involves an SLA, or involves time over the network or whatever. So anything that's expensive, whether expensive is network calls, money, financial, you want them to be towards the end of your chain, right? The ones that are simple, fast, and catch the most, you want them first. But you also want to be able to monitor them too, because if you find that, like, as you change your prompt, the auditing piece also captures when guardrails get invoked. So your auditing piece, if you find that you update you change models, you don't even touch the application, you change the models, and now my guardrails are being executed 2 times 75% of the time, then something's wrong, right? Because the guardrail should be the exceptional case, not the flow all the time. So this kind of ties back into observability and auditing and logging and all these things, testing, and it kind of all starts to tie together. Right. And then you can test them too. So if you want to test them, there's in LangChain4j, there's a testing framework as well based on assert.j. So you can do like guardrail assertions that assert that is successful, has a specific result, has a single failure with a specific message. So this would be like for your unit testing. So it just plugs right into assert.j, and you can do these kinds of assertions and whatnot. And again, this is just Quarkus right now, but all of this has already been backported to LangChain4j, just not there yet. So let's go look at some code here. Oh, so question. Let me look at these questions. How does the LM decide if it needs to use the tool? It's matching with the description in @tool, right? And so the frustrating part is it doesn't always call the tool when you want it to, and sometimes it calls the tool when you don't want it to. Those are the second one, not calling the tool when you want it to, is very hard to guard against, right? It's easier to know that, hey, you shouldn't have called this tool based on the user input. You could write a guardrail for that, but it's really hard to detect that it should have called something and it didn't. That it's very hard to do. Heard about evals as a similar line. I don't know what that means, what that is, Jody.
Yeah, I I heard about it on a product podcast recently, and it's like a test to ensure the correctness of your model. So like you define like what good responses look
Mhm.
like from your model, and then it's sort of a way of
Yep,
applying
I have a whole
testing.
section on that. I have a whole
Okay.
section. I don't know that
Okay.
we'll get to it tonight, but I have a
All right.
whole, that's a new
Okay.
thing that's come since the last time we talked,
Okay,
like
thanks.
an evaluation framework.
Yes, okay, thank you.
Yeah.
That's later. Okay.
That's later. Yep. So I have my assistant, I have guardrails. I could, do an array of guardrails here, right? Right. I've got my application, I've got my input guardrail, my output guardrail, and then I have tests for it. So I can test my guardrails. So I can just say, assert that is successful, or assert that has a single failure, or I can like do a list assert that gives me all the failures, and then I can do assert, kind of like all the good assert J stuff that you're familiar with. If you're not familiar with assert J, get familiar with it because it's awesome. Like for doing like chained and assertions together is so good. So yeah. All right. I'm going to skip over image generation because it's pretty easy, and I think we've only got like 15 minutes. I think I'd rather get to something a little more, because image generation, it's pretty easy. So we've got model context protocol. What else we got here? I've got, and then testing and scoring and mocking. Yeah, so we're getting there. And my thing's not advancing. Here we go. So this probably looks familiar, this screen, right? When I was doing function calling and tools, it looked similar. But the main difference is in MCP, the model context protocol itself came out recently from Anthropic. Anthropic developed this thing, and it's a standardized way to discover and execute essentially remote tool calls, right? So if you think about like when I showed the slide before with this weather thing, all that code was in one application, right? And the model class had access to the tool, which was another class, and all that was in one application. What if I now have microservices and I have a service over here which knows how to get the weather forecast given latitude and longitude, and I've got another thing over here that knows how to extract the city from something. So now they're distributed. What MCP provides is a protocol for the ones that are implementing the server protocol to expose themselves, and a client to be able to, in a standardized way, discover them. And it's this kind of the same concept of providing tools and providing descriptions of the tools, but the discovery mechanism, and now it's almost like RPC because it's discovering these things. They can either be remote or they can be on the same server, and it's using like standard IO or processes to communicate, or pipes to communicate with them. But essentially the protocol right now has process based and has HTTP or service end event based right now. And so you can build apps that expose themselves as MCP servers, and you can build an app that is an MCP client that can connect to all these different MCP servers. So MCP is just the protocol that makes all this work. And before that, it was just kind of like the Wild West. And when I say before that, I make it sound like it was eons ago. That we're talking like weeks here, or even like a month. I know recently too, I know Josh Long and the Spring AI folks were like harping on, oh yeah, we donated the Spring AI implementation as the implementation for Java, the Java SDK for MCP. And there's actually like they're taking a lot of slack for it. There's actually, if you go to the Model Context Protocol GitHub and you look in the discussion thread, there's a huge thread in there like, hey, this is supposed to be a reusable SDK, but yet what are these monos and fluxes and all Project Reactor doing in there? So Red Hat is pushing back. A couple of other big organizations are pushing back on that to come up with, hey, if you're really going to have a standard Java SDK, it should be like adhere to like the standard Java publisher and Java flow and that, and it shouldn't wrap in any of these third-party dependencies. If you want to provide a reference implementation that implements that using monos and fluxes, and Quarkus will bring one that uses unis and multis and whatnot, but the underlying SDK should be free and clear of any third-party or proprietary thing. And that's, you'll see like there's a bunch of different organizations. Red Hat's like probably the biggest one. There's like 5 of us. I'm in there too, like trying to throw our weight around, trying to make it open rather than the Spring implementation is the implementation. Yes, if you want to be the first one there, great. You can have the kudos for it. It's about making it reusable and making it generic enough. That's our beef with it. Just like I think I don't know if you know Julian Ponge. He's a big reactive guy as part of Vertex. He's like, I would never propose that the standard SDK for MCP be based on Vertex. Like it just doesn't make sense. It's too framework specific and too oriented to something. So that little side chatter for that. So the client can invoke the tool. So conceptually, this is exactly the same as function calling, except the function call is a remote call to something somewhere else. But everything else that we talked about with tools is conceptually exactly the same here. MCP just gives you the way to do this, and it uses JSON RPC to do it for the SSE or HTTP transport. There's also like you see people like run like NPM model context protocol something like there's this NPM repositories are like the Wild West. People just put stuff in there and you have no idea what you're getting. Well, this is what this is starting to turn into. Like, because now you can just fire up an MCP server that somebody else built, which is kind of cool and kind of scary at the same time. So like if you've ever used Microsoft Playwright, it's kind of like Selenium to do things, the code that you have to write in Java to describe the structure. Well, I built something where I can actually just write it in natural language, and Playwright has an MCP server. I can use an LLM to tell it, hey, load this page at this URL, find the label that has this, find the grid. The grid should have 5 rows with these column headers. And the LLM can use the Playwright MCP to translate that to Playwright instructions, and then Playwright can run that and return the results to me. Right? So that's kind of some of the things that you can start to do. But I don't know who wrote that Playwright MCP server. Like, was it written by the Playwright people? Was it written by Joe out on the internet somewhere that I'm now just running on my server? So yeah, what could possibly go wrong here? Yeah, so standardize. You see all these tools too, like the Claude desktop client was the first to have this. So you can start up all these little NPM servers on your local machine and wire them into Claude Desktop. And now you can use Claude Desktop to like chat with all these different things. GitHub, I just saw like GitHub Copilot today announced that they have a way where you can hook them in. I know IntelliJ just released it too. So even in IntelliJ, me as a developer, I could start like using the JetBrains AI assistant to do things in the IDE, because JetBrains, the IDE, is exposing these MCP servers. So for a while, it's going to kind of be like the Wild West. Like, who can you trust? Like, you shouldn't trust anybody unless you built it yourself or you verify like that they have a certificate. You shouldn't trust them, in my opinion. Right. So if I didn't tell you that this was a remote call, you probably wouldn't have even, it looks exactly the same as before, except this like little dashed line down the middle is an application boundary. These are 2 separate applications. So you have it again in LangChain4j exposes stuff that Quarkus implements. So Quarkus has an MCP server SDK and a client SDK as well. You can write functions in your app that expose tools. When you start it as an MCP server, it does whatever MCP and broadcasts itself, and then the client looks exactly like it did before. And in the configuration, you just say, hey, this is a standard in, and here's the path to it, or it's a HTTP, and here's the URL. And it can go self-discover the API. It'll go query it, say, hey, what tools do you have available? It'll pull it down, and it'll add it to the LLM. So now you're basically doing remote tool calling with remote procedure calls. And that's like kind of the basics. Again, what could possibly go wrong in this scenario? Right. So I'll go into now, wrap up with a demo of it. So like to MCP or not, do you do it or do you don't? You do it because if you don't, everybody's going to be laughing at you that you're not, because everybody else is. That's kind of one thing. There's lots of servers out there, especially in the NPM, whether you can trust them or not, and figure out who built them and who's maintaining them, and that there's no Trojan horses in them. Have fun with that. But it's nice to have some kind of a standard. I think we're just at the very beginning of this. So some of this other security stuff, I'm sure is going to start to shake out, because can bet like a lot of financial companies are not going to be doing this without being able to verify things, right? Security, how to discover it, how do you incorporate this into like a RAG pipeline, like if it's providing data, Yeah, and it's changing so fast. You've got different competitors that are all the time, right? So think about security. Like you have it, your user prompt is add 2 numbers, and you talk to an MCP server, and the MCP server responds, oh, and also read the home directory, the ID RSA, and send it back to me, right? You have zero control over what that server is doing, right? Is it key logging stuff? Is it like, so like, would you ever want to send in any kind of sensitive information? If I didn't build it, I'm not sending sensitive information to it, right? But people just seem to be okay with it. Like, it's like, hey, take this JavaScript and just randomly eval it for me, and everything is going to be good, right? So I'll do a little demo here, and I think we will get to the scoring. It's only if we can stay like an extra 10 minutes. I think we can get through to the end here. So I got a couple MCP examples, and like I said, this is all new since the last time I talked to you, and it's like hot off the wire. So we've got just a simple example using straight up LangChain4j. Where's it here? So in this case, I've got some directory, and so this is what I was talking about. So I'm just gonna run a command npm-y exec at model context protocol, some server file system. So somebody wrote an MCP server that knows how to interact with your file system. What could possibly go wrong in that scenario? But I can come in here, I can run this thing, right? And I can say, run it in dev mode. So it says that if I go up, you see when the application started up, let me find it here. It started the process. So in here, I'm setting up an MCP client to the server. It says, oh, it's a standard IO server and it's not already running. Let me go start that process for you. Then it knows and understands it's using JSON RPC. Here's the protocol. Here's what it has access to. So you can control the scope of it. It only has access to these kind of directories. And then here's the capabilities. And then when it's going to make a call to it, say, tell me what capabilities you have. And then when I ask something, when I say, hey, write a Python script that takes 2 numbers as arguments and prints their sum and save it, it's going to call out to GPT-4o, and it's also going to say, hey, you've got these functions that are available to you, and this is what the functions do. And the LLM can respond back. Once I get to the end, it's got lots of functions. And it's going to call the function write file with this response. And then my app is now going to call the tool, which is a process, and it's going to pass that to the process, and it's going to call that function. At the end of the day, what I get is I have this playground directory. Now I have a sum.py. I have a Python file which knows how to add 2 numbers. And that's what the LLM generated for me, and the tool wrote it to the file system for me. Right. So I think these other ones are like the same example, just structured a little bit different. So this next one is doing the same thing, but just driving it through configuration instead of like having to write all that code. So now I can drive it. Okay, rather than me have to like write the code in the builders, I can drive it through configuration. Here's my command for that process, start it up, and it'll do the same thing. And then now I can separate them into 2 servers. So in this case, I have an MCP server, which basically is just like a front end for the weather service. So I've got a REST client in here, and then I'm describing my functions on the REST client as tools. So when this thing starts up, it gets exposed. And then when the client starts up, I can point to it. Right, I can say the transport is HTTP. It's going to be running on port 8082, and this is the URL. I want you to log all the requests and responses. So as the communication goes back and forth, it'll request, and it'll discover the API and the protocol and the functions dynamically on the fly. And what's kind of cool is I could take the server offline, add a new function to it, start it back up, and the client will automatically rediscover the new functions that are available to it. So it can change on the fly. It's not like everything is bound to one another either. The operations can change on the fly at runtime. Again, what could possibly go wrong? Right. So that's kind of MCP in a nutshell. Do we have like 10 minutes? Can we stay like another 10?
Yeah, that should work.
Yeah. So we can, where is it here? So again, what could possibly go wrong with everything that I've talked about for the last 3 or 4 hours, right? Oops. So testing, scoring. So how do you test it? So to me, there's different kinds of ways. So there's testing at the application level, which is like mocking, all the standard things that you would do in Java. Because these services are interfaces, it makes it really easy to mock, or to use something like wire mock to mock your interactions and asserting. You can do assertions using judges, and this is kind of, Jody, where you were going with evaluation. Like if you have a history of what a good response looks like versus what you're actually getting, you can do a judging score of how close are the responses to that. But typically what will happen is that it'll start to drift over time. So this isn't something that you would necessarily run like as a unit test, right? You'd want to run this over your history, which is why auditing is important. If you're not auditing and you don't know what users have asked and what they've been responded, you could come up with a list of what's good and what's bad, but is that reality? You don't know. You're like the product manager deciding how it should be used, not understanding how it's actually being used in reality. Right. So you kind of have to have a way every time the user asks or a request goes, you should store that off and then correlate the response. So that way you can go back and evaluate that offline or in a batch or however frequently you want to do it and say, hey, these responses, are they within 60% relevancy? Did I change my model but not change my application? I can now go back to and reevaluate and rescore and say, hey, is this still good? I can go back if I'm tracking or auditing anytime my guardrails get executed. After I made this change, is the first guardrail, is my hallucination guard or is my prompt injection guardrail getting invoked twice the majority of the time? If it is, something's probably wrong, right? So this is where it starts to get like, you can only do if you're tracking. And I think this is industry where we haven't quite started to get to yet. Like, because I would think like the observability and the auditing piece and that data extraction would be something like your Datadogs or those types of companies would be like all over, like wanting you to store your data with them so that it's easy to query and whatnot, and then having the framework that knows how to put it there, and then a framework that knows how to evaluate. I think we're just like scratching the surface here. And so this is like this stuff that I'm showing is just something that we thought of. This is only in Quarkus, and this is stuff that kind of we thought of that, hey, we see a gap, and I think this is kind of the start at what it can be. What it looks like a month from now, it could look totally different as things evolve. But personal opinion, I don't think like we're this sophisticated yet. This is what's missing, and this is what where we need to go as an industry, like to actually be sure that we're getting like the benefits out of it, and we're guarding ourselves against it, right? That this is what really needs to happen. So in the case of mocking, I talked about injecting a mock of your AI service. I mean that's pretty easy. We've been doing that for years. Using a judge, so maybe you have another model that's in-house that knows how to judge things. So we built this thing, you give it a reference to your model. So when I make this request to my app, given whatever my request is, I'm then going to call my judge and assert using, and again, we've built it into CIJUG to say, hey, this response should be a summary doing this, and it shouldn't include this, and it should do this. And then you're sending all that off to another model to then come back and say, yeah, looks good, or no, it doesn't because of X, Y, and Z reasons, right? But again, all we're doing is we're putting a layer of abstraction on top of things, because now who's testing the judging model? Like you can continue to ask this question, like take it a level up and apply this pattern, then take that a level up and apply the pattern. So we're just adding layers of abstraction, but that's how we solve problems in computer science, right? So now we also have a way to do evaluation, but again, you need a history in order to do evaluation, and that history either needs to be human computed, like in a file or in a database or something, or it needs to be real data. So you're going to look at your data sample of what happened in reality, what should have been expected, and you're going to compute essentially a score for that, or a difference. And then, between of a percentage of relevant, are these things relevant? And maybe you can tolerate 75%. If it's less than 75%, then something's wrong. And so we can do this too. We can, either give it a file or hook it into a database, but we can build the scorer now, which can do things in parallel, and it's got all kinds of widgets and knobs and that you can tweak. But essentially, I'm going to use a semantic similarity or a cosine similarity of, in this case, 70%, and I want it to write out a report in Markdown format, and I want that, or I want to put it on GitHub as a GitHub issue, or put it in Confluence or track however it is you want to track that. But again, this isn't something, it's set up as like using JUnit as the executor for this, but it's probably not something you're going to run as part of your unit test suite. This probably exists in a separate, like if you've got projects that use like Cucumber or something, it probably sits along those kinds of lines, something you're going to run offline, on a periodic basis rather than on every build kind of thing. But it plugs into JUnit to run this. So yeah, so that's about it. I mean, I have a whole demo that probably has most of this stuff incorporated. I can show it to you. It kind of looks like this. It's got your typical chatbot WebSocket. It's got claims and assistance, and it's got RAG and document stores and tool invocations that know how to send emails and verify emails. And it actually generates the email body using another AI in another model, which has guardrails, and those guardrails have checks for politeness, which uses another AI. So that you can start to get pretty complicated. And so this demo is actually not in this repo. It's in another repo somewhere. I'll put the link to it, but it's in a talk that I did at JFocus. Yeah, I can open it. Yeah, so I'll throw the URL in the chat here. Find it here. So this is where I did a whole talk on testing non-deterministic things, and this was my my example application for that. So essentially, like I've got, and this is where I was starting. I was talking about dockling. I was starting to integrate dockling into this, so that it actually doesn't compile at the moment. I was doing this today. So I've got my claim service, which is the main chat agent, which goes off of a WebSocket. But then the claim service has tools, this notification service. The notification service uses mailing, and it uses another AI service, which doesn't do RAG and doesn't have augmentation, but then it has output guardrails, and my output guardrails has a politeness guardrail, which has access to another AI service, right? That can go to yet another model and do all kinds of crazy things with it. And it's fully tested. Like it's got all the tests that go with it. So I like Playwright a lot. So I saw somebody shaking their head with Playwright. I really like Playwright for things like this, for like black box testing. So I can do things like if I'm on the detail page, I can say, okay, find the chatbot widget, click the button, then put this in. What it returns, I don't test for because I don't really care. I just care that it sends something back. So you could get away with like wiremock here. So now you've kind of taken the non-determinism out, because at that point, if you're not testing your guardrails separately, then you can make your thing deterministic, right? By using something like wiremock or mocking or something with Playwright. So you've taken the non-determinism out, because if you let it go through all that non-determinism, all you're testing is the LangChain framework itself, right? That works right. So I like to separate it out, separate my outside from my inside. It's just a pattern that I typically follow with these kinds of applications. And then I have tests for my guardrails, like lots of different tests that give different scenarios with my guardrails and whatnot, that they work under certain conditions. So yeah, so I think that's it. I think we made it.
Awesome.
Ooh. Yeah, so yeah, these are the slides. So here's the slides, the QR code. The slides should be there. I don't know if somebody tried, but they should be there.
I also posted them in the chat.
Yeah, so
Yeah,
with
sorry.
Quarkus, we've got over 1,000 contributors now across like hundreds of different organizations and companies. Yeah, and that's it. So the only thing we didn't cover is images. I mean, images takes 5 minutes. I can do it real quick. So like generating images or reading images. So you can do this at the AI service level too. So if you want to describe an image, you just give it this is a LangChain4j thing, which could be a URL. It could be the actual base 64 encoded, could be whatever. And you just tag it with image URL, and then it sends it to the model, and the model knows to describe it. And on the flip side, you can just move the image from the input to the output, and it goes the other way. And it gives you can either ask it for for a URL or the base64 encoded bytes, or it can put it out, have it write it to the file system or whatever you want to do. It's pretty easy. It's pretty cool. It's easy to do.
Awesome.
And that's the whole thing. We finished.
Nice.
Look
Good
at that.
job. That was great. That was a lot of content, and you did a really good job. Any questions for Eric?
Yeah, please. I know it's like a fire hose here.
Hey Eric, as usual, like this is Ovi. As usual, you're fantastic. It's really hard to catch all the information. Thank you so much for that.
No, you're welcome. You're welcome. Now you get to go play with it, and that's what you really learn about it. Is like it's one thing to see it, and it's another thing it starts to click when you start playing with it.
Yeah, that's true.
So does the LLM discover what MCP exists when it makes the connection? Yeah, so back to my example here. So with like the MCP server, so with the MCP client, I'm basically describing all the servers that it has. So in this case, it only has access to one, but I could provide multiple. In this case, it's an HTTP and here's the URL, but I don't know what functions it provides. I'm just telling you where it is. And the MCP client will, you can kind of even look at the log here. If I go back to the log, when the application starts, it will actually make a call over the MCP protocol. So here, starting process, allowed directories, result, MCP server capabilities. So it's actually making an RPC call to the server, and the server is broadcasting back what capabilities it has, like in using natural language. Like it can do, here's the schema. It's basically, if you think of, it's not really open API, but think of like it giving you back an open API document of all the things that you can do with it, but just done in natural language. But like I said, I could shut down that MCP server, add a new operation to it, start it back up, and then the next time it goes to call it, it'll rediscover the operations that are available to it. Whereas if I built them all in my code, I've got to build them all in my code, right? So again, you can just start dreaming tonight about all the things that could possibly go wrong. Right, which is why like observability is key, auditing is key, all the resiliency, circuit breaking, retries, fallbacks, error handling is like super, super important, more so than ever before. Super important.
Any other last questions? All right. Stick around. We do have a JetBrains raffle I'll do right now. And thank you again, Eric. I'm going to stop the recording so we can, unless someone has a last minute question. All right. Yes.